All right, good evening, everybody. It's Monday. It's 9 o'clock. It's time for the Tropical Update. I'm David Paul. Welcome to the KHOU 11 Weather Center. We do have Tropical Storm Bertha now in the Gulf, just upgraded as of the 7 o'clock intermediate advisory from the Hurricane Center. We're going to get to all that here immediately. First, here we are, July 20th, and yes, we are in the time when statistically we do begin to see tropical storm activity over the years begin to ramp up this time of the year, especially second half of July. So not a surprise that we now have Bertha out there. And so this makes two storms this season. We've had Arthur, we've had Bertha. Arthur directly hit Houston, Galveston as a tropical storm. But because the wind shear was so strong with Arthur, all the rain and strong storms were so far displaced, they were in New Orleans, the storms, while the center of the low-level center was hitting Houston, Galveston. We ended up with a breezy day, and that was about it. It was the quietest you'd ever see a tropical storm making landfall as far as impacts go. Certainly that I've ever seen, and to experience it firsthand was quite odd. Bertha may do the exact same thing. This storm is in an incredibly sheared environment. It's interacting with land, and it looks like it's going to graze New Orleans, but they may just get a breezy day out of Tropical Storm Bertha, and that's about it. It is interesting. This is the forecast from Colorado State. Their April storm count forecast was for 13 total named storms. A normal year is 14. Then we went into July, and they dropped their forecast to 9 named systems. So we've had 2 now. So one in June, one in July. So that puts us on track for a normal season. That would put us on track to hit 13, 14 named storms. We'll see. Sea surface temps, now this is where Bertha is developing. It's bathwater. It's upper 80s, 87, 88. So there's plenty of energy for a storm to feed on. But the energy at the sea surface, these temperatures that are 80 and above, it's just like initial conditions. Once you hit 80 or above, you can have a tropical storm or hurricane, anything from a weak tropical storm like Bertha all the way to a Cat 5. After reaching the sea surface temperature criteria, what matters much more is upper level wind pattern. Is it in a sheared environment? Is it in an unsheared environment? Is there outflow at all quadrants? It really has to do with mid and upper level flow more than sea surface temperature. So we've met our baseline criteria, but just because sea surface temperatures are near 90 doesn't mean we're going to have a big, strong storm. So let's start with the forecast from the Hurricane Center. This is Bertha as of 7 o'clock, tropical storm, winds at 40. So it's a minimal tropical storm. Minimal tropical storm force winds are 39. So 40 is minimal tropical storm. It's barely reached that criteria today. Gust to 45. It's basically stationary, moving northwest at 3. Lowest pressure measured is down to 1,004 millibars. It is forecast to move west. It is already sort of interacting with land because it's close to the continental U.S. The counterclockwise flow is already pulling dry air in off the mainland into the system. That's one of the reasons why it struggled to strengthen today. It's also being sheared. We're going to look at that in a minute. It's also, interacting with land, or is forecast to graze by the coast of Louisiana. And once that system gets over land, it'll completely dissipate. It may just sort of straddle the coastline, but that would keep it very weak. And if you look at the forecast intensity, tomorrow we may peak at 50-mile-an-hour winds before it actually makes landfall anywhere. Thursday, dropping to 40-mile-an-hour winds. So New Orleans may get a minimal tropical storm going into Thursday early morning. 35-mile-an-hour winds by Thursday afternoon, then winds drop to 30 and 25 as it reaches Texas, if it reaches Texas at all. Satellite enhanced. We see the colder cloud tops are in bright red. And as you look down at this, it really looks disorganized, and it is. I've put on the surface streamline, so these are the surface winds. So the center is here. So this is exactly what Arthur did. Arthur was sheared, so the center is exposed in Bertha. It was like that with Arthur. The wind shear is pushing all the convection, the thunderstorm activity, off to the south and west of the center. To get a storm to strengthen, you need to have convection, thunderstorms surrounding and over the center. That's where pressures drop and you can get intensification of that surface pressure, and that allows the storm to really strengthen and intensify. But when this thunderstorm activity is displaced from the center, very difficult to strengthen, and most likely you're talking about a storm that's weakening. That's the surface. Upper levels. So this is at about 28,000 feet. And look at the shear, look at the wind flow just coming in and blowing right across. And that's why you see the thunderstorm activity blown off to the southwest of the actual center. It is displaced. And we've talked a lot about wind shear. So that's the shear. Those are also the steering currents. So once it gets fully caught up in that, if it's still an entity, it will move west or maybe west-southwest. Now remember, the Coriolis force wants it to go poleward. The steering currents here want it to go southwest. So that's why you see kind of a balance in the forecast from the Hurricane Center moving almost due west. So this is just an oversimplification of the wind shear that's been cutting across the storm. And you can see, look at how far the clouds, hundreds of miles, blown off to the west. You know, this is a sheared environment, so very difficult for a storm to get going in that. And we talk about this quite a bit. To get a storm to develop, become a strong hurricane, it needs an unsheared environment, so it can be vertically stacked. That allows for the circulation to get organized, and you can get very powerful storms in an unsheared environment, especially if you have outflow at the top. It's like an exhaust. It's like an unclogged exhaust. Wind shear is sort of like clogging the exhaust, and it tilts everything over. So everything gets disturbed, the circulation gets disrupted. Under strong wind shear like we're seeing, not only does it get tilted, but the storms can get totally displaced from the low-level developing center. And that is a recipe for a storm to stay weak or not be able to develop at all. Why is it like this right now? The big pattern across the United States doesn't get more clear-cut than this. Big area of high pressure. That is a ridge of high pressure in the upper levels. These are the upper level winds. And there they are, cutting across our developing Bertha and displacing the storms from the center, also pulling in dry air. The position of the storm system is near land. It has a lot working against it to strengthen. And there we are, the upper level winds going into Tuesday. This high pressure dome is going nowhere. And you see the green here, that's the backside. That's pulling in Pacific moisture. It's monsoon season in the desert southwest and the mountain west. Okay, so let's look at the global models first. When I say global, we're talking about the lower resolution American model and GFS. And this is the Euro. It very closely mirrors the last several runs of the GFS. So I'm going to use it as our example of our global lower resolution model. And it has our Tropical Storm Bertha sitting right here. It's initiated correctly. Notice how the modeling suggests that there would be a lot more rain and thunderstorms near the center than there actually is. So it's got the right spot, but it does not have a good handle on the convection and the thunderstorm activity, which at the moment is very limited. When I put this in motion, you'll see it drift northwest, bump into land, and then just dissipate. That's tomorrow afternoon, and there's going into Wednesday, Thursday. So it's possible, if that verifies, that we're going to have it just dissipate right here. We'll see whatever rain elongated by the upper level winds shearing it off, and Houston, Texas would see zero impacts if that were to happen. It's not out of the question that is the final scenario coming up here. So New Orleans to Mobile to Pensacola to the Big Bend would get some rain in breezy conditions, and that would be about it. The high resolution models have been consistent in having a little further southern component to the track. So here's, I immediately pushed into Tuesday, 10 p.m. Let's just go over this again. So here we are now. And I like the high res. It is initiated a little bit better. So it has the center in the right spot, but it also has most of the convection already sheared to the southwest. So it's picking up on that mid and upper level shear a little bit better than the low resolution global models. And we go into Tuesday morning, awfully close, not only awfully close, but look at how the circulation, the northern edge of it, is interacting with the landmass of Florida. That could weaken the storm back to depression if the thunderstorms remain displaced from the center. There we are Tuesday night, and we go into Wednesday afternoon. And at this point, you know, our circulation is impacting New Orleans. Let's just say this is still a low-end tropical storm, winds of 40. What does this mean for New Orleans on Wednesday afternoon? It means you get a breezy day with all the convection blown off to the southwest by that upper level wind shear. It means you get what we had with Arthur. It's a tropical storm, but the convection's all displaced. So you just get a breezy day in New Orleans like we had with Arthur. Just amazing outcome we had with Arthur. That is Wednesday afternoon. And then let's take it into Thursday morning. So if the circulation survives, we go into Thursday morning and there's our circulation. Broad, elongated, maybe just a remnant low at this time, maybe a tropical storm. But look again, we're getting a north breeze coming off the mainland. That's bringing in dry air, so that zaps the rain chance. We're on the dry side. The wet and dirty side is still out here, and with the upper level shear cutting across it, it's pushing all the thunderstorm activity out into the Gulf and down to the Valley of Texas. That's Thursday morning. And then there is Thursday, 1:30 in the afternoon. Excuse me. Broad, elongating circulation, half inland or almost all inland right now. Scattered showers, a better chance from Matagorda Bay, Port Lavaca, down to Corpus, down to Padre Island. Maybe an isolated shower on the backside. So because of that, I've put in a 20% chance for a scattered shower in the Thursday, Friday time frame. Maybe it's a little breezy. There may be a little bit of an elevated surf and sea situation on the coast. But that would be it if that scenario plays out. That's if the low can come all the way across to Texas. Remember, the global models are suggesting it may go inland and dissipate. So to put it in words, time frame, Thursday, Friday. This is for Houston, Galveston. When would we feel impacts? It would be in the Thursday, Friday time frame. North breeze at 15 to 25, and a 20% chance for an isolated shower. That's the most likely outcome if we're going to get the storm, the circulation all the way over here. Thursday, Friday. Let's look at what we look at every night, the GFS and the Euro. So again, these are the big global models. And you'll remember what I do with this is I don't show anything unless we get down to 1,010 millibars or below. So we're at 1,004 with Bertha right now, and that's why it is showing up. There it is. Sometimes I look at the model, I wonder if it's working. At least we know it works. That's Bertha this evening. So we're looking in this area for anything that looks like that to begin to develop that could potentially impact us. We go forward in time to Tuesday and Wednesday. And notice, so Wednesday, the yellow, the American model has our system half inland at the mouth of the Mississippi River. The Euro in red has the system inland north of Mobile Bay. So again, the global models are a little more, we're going to take it in here and dissipate it before it gets to Texas. That is a hurricane in the Pacific. Other than that, nothing else in our main development region. We go into Thursday, Friday, Saturday, everything's dissipated by then. We go all the way into early next week. Broad area of low pressure across the continental United States, but again, nothing showing up in Gulf, Carib, Atlantic. We go further out, Tuesday, there goes a North Atlantic low. 2 systems in the Pacific. Nada for us going into next week. So that is where we stand. Yeah, and this is another way to look at our potential impacts, which are minimal at the moment. I've put in a 20% chance for an isolated shower Thursday, Friday, maybe Saturday. staying hot. And that's really what we've got in Houston, Galveston for the next couple of days as this system decides what it wants to do. A slight dip in humidity will allow temperatures to go hotter. So 99 on Tuesday, heat advisory is in effect Tuesday, 100 on Wednesday, 101 on Thursday, 99 on Friday as the heat really builds underneath this heat dome that our system is traversing around and being impacted by. That's where we stand in the tropics tonight. We're going to get an update from the Hurricane Center, a track update as well, just before the 10 o'clock news. So we'll see you live at 10 o'clock for the next update on Bertha and all the news and weather and sports and headlines of the day. We'll see you at 10.